time mark for both audio and video sync. Okay. So here we have all of these screws and all of the system. So let me just grab this because it should be fine. There we go. There. Okay. So we have roughly. Oh, I've probably done this before. Let's see. We have 3 volt times length 10. 3 volt 12 times. So in this case, it doesn't really matter if you go with like M3s with the length of 12 or 10. It just gives you a little bit more length on the other end of the bolts or the nuts. So that doesn't really matter. So what I'm going to show you today is how to assemble the Rudolph V5 and all of the components that goes into it. And I of course have it in 2 different views where you can both see me but also see with my hands what I'm actually doing. So I started out by laying out all of the tools that will be needed. Firstly, we have a screwdriver. That's kind of obvious. Screws, nuts and bolts. We have I think it's an Umbraco 5. Just a big enough size for the screws we have for the caster wheels. We have a single spanner. This one is also for the caster wheels, so these two will only be used for one thing. And then I have a tong. Had I been more inclined with tools, I would have had a M3 spanner as well to use that. For obvious reasons, that would be best for the screws themselves and the nuts and bolts themselves. But I don't have that, so therefore we aren't going with that currently. So let's get started. The first thing we have to do is take the bottom plate, which is this, which can be seen by having both the Raspberry Pi and the caster wheel, as well as the motors, the battery, and all of that, with all of these holes. It'll also be labeled in the documentation, so it should be easy to find out what is what. So first, we'll have to take the brackets that is going for the motor, put that on at the bottom, and apply here I would recommend that you use the 12 millimeters, the 10 millimeters M3s, because if we use the long ones, there'll be a larger protrusion than is technically necessary. So we can't just limit ourselves to the smaller ones to increase the chance of them looking nice. It isn't a requirement in any stretch of the imagination. It's just this is a thing that you can do for yourself to make it look a little bit nicer. And also here it would be interchangeable with the length of the nuts and bolts if you have it one way or the other. Preferences aside, I am probably more of a screw head on top. I didn't do it this time, but I would probably do that if I wanted to make this look pretty. But right now, that's really not what is important. This is more of a just showing how to do this for people who haven't been like building this system, sitting with it like for way too many hours. Why are you being misaligned slightly? Okay, let's see. Just do. So we'll just do that. So if the things are slightly misaligned, you can just, because of the acrylic plate, like screw it in, which, yes, that's the right one. Because then you are able to, oh, I dropped a bit, that's fine. There we go, should probably grab a bit. Always, when working with acrylic, don't tighten it too hard because you can make it break. It's very crucial that you keep the corner one, like here, keep that unoccupied for now because we will use that later for an offset instead. So, to the next one. And then it wouldn't surprise me if I was being dumb and actually just added it straight away. But I just told you not to. Well, isn't that what this is all about? Don't do what I do, but do what I say, because otherwise this just won't be nice. Because it's always like that, right? I might totally like misunderstood how the world is right now. I wouldn't even surprise me either, because I'm a bit of an idiot, and I love being an idiot. So don't worry about it. So now just add this one. Is that this one? Just do this. Okay, so now we take the tongue and tighten all the screws on both of the spans. This is sort of important just to make sure that like you don't drop the screws like halfway through a test or anything, because I have had that happen. Like if you don't tighten it well, at some point you will lose it, and it's sort of sucks to have to go back and go like, oh, fuck. Especially when you have the motor to be like as much in the way as it will be. So like it really isn't nice to have to go back. Let's see there, and last one. Fine, cool. So now these three have been tightened. Before we go further, we will now add the battery holder on the bottom. It should be this one, this top one, and this one. So the short one, or the, sorry, not as wide one, is the battery holder on the bottom, which is the one we are going to add first, for the purposes of making sure that we have the ability to add like our battery, so that is able to be like fixed in place, so we don't have it just ruffling around, because that would also be sort of annoying. There we go. A bit of tight, so we do it like that. Tongue, the plier. And I will say that here there isn't a wrong way of doing this. This is just like, as long as it lines up, it should be fine. It should be fine. There we go. This is primarily just for like the sake of keeping the battery like in a location that you want it to be. Because if you don't, this right now won't be an issue, but the next step, which is now we want to add the top one. And here it is important that we turn this one right around. So here, as you can see on the part here, it has a cut corner. That is important, because that has to go where the bolt that we just put in for the motor bracket, so that it doesn't occlude itself. So those are important. Keep that in mind when you now put it in. Oh, penis. There we go. So now we put everything on, and of course it's a newly printed thing and I haven't drawn it out because I'm a bit of an idiot. There we go. So now we just add. See, now I'm also being consistent about the way that our thing is placed. So now everything will be with like the knots on the top. Not because it looks particularly prettier, it really doesn't. I actually dislike it a fair bit, but it's fine. It makes it look a little dumber, but like, who's gonna care? Realistically, it's basically you. And like, this isn't a wrong design choice. Like, this is just it looks worse in my opinion. That's why I would recommend you not do this. Okay, so now we have to add this one, which is the backplate. This one also is very important, but I think it makes sense that you wouldn't place it with the backplate of it like here against the, like on the wrong way, because we want this to be the thing holding the battery, both in the like direction that it's getting inserted at, but also we want it to be able to hold it on the axis that's going to drop at. So sort of important that you don't turn this around, but I don't see how you would put this wrong. Like, I would honestly, I think that would require a level of skill that I do not perceive as normal for people doing these kinds of tasks. So I would not expect this to be an issue for at least most people doing this, because most people can use their eyes and are able to think a little bit critically. If you're not, that's a lie. I know you can. There we go. Just adding another knot. So now we are like slowly tightening everything, making sure everything is nice and tight enough, but not too tight. So, important. There we go. Now we will add the bottom bracket. This one doesn't. Oh fuck! I forgot to add that. Penis. Okay. Go right wrong way. This way. So all of the screws that I've been, or bolts that I've been adding right now are all for the, M3s, and a mixture of the like 12 mm length and the 10 mm length. And of course, it doesn't really matter which one you put in. I just put the ones in I think are more preferable to look at. Go. But there is no wrong way of doing this, so don't worry about it. Like, I would argue that you're basically not able to like put this anywhere. I think a little bit of the sequencing is like more important actually, because that you would definitely be wrong, and I know that because I built it wrong the first time I built it, whilst I was in the middle of designing it. So now we have. So now we've added the things, the only things that's actually going to go on the bottom below the we still need the caster wheel, which will be the next thing. We take the caster wheel, put it on, put the screw from this bottom. I prefer the top for this specific thing, just because it's a little bit. So here is where we use the other of this band from before, in different places. And there we go. Just keeping it slightly loose so that I still have a little bit of room for all of the other screws. There we go. So now it's just nuts that needs to be locked in, and of course. Any knot here would do, but I would strongly recommend that you go with a large enough size that it like fits the hole, so you don't have to add like discs here, because that will make it a little bit not iffy or anything. Just it's not as nice to operate. So now we can take this again, not too tight. just a bit. So now we have everything on the bottom that needs to be attached to the bottom plate. So now we're going to attach the motors. So the reason why we wouldn't want to do that before is because then we would have some occlusions on this end. Oh, I did it bad. Fuck. Yes, I did it bad. I even knew that I did it bad when I did it. So me saying that you can't do it wrong and then I immediately do it wrong, is that how I expressly told that this was gonna go? Yes, I did. Because I'm an idiot. So it's great, don't worry about it. Even like the guy who fucking designed this can do it wrong. So like, there's literally nothing inherently like bad in doing it in a different manner than what I did, because don't worry about it, I did it wrong probably a buttload of time before you even like thought about it, and I probably did something wrong many times that you didn't even think you could do wrong. So don't worry about it. It's like it's not bad. But yeah, here it is slightly important that you keep in mind that the back sides of this has to be on this side to make enough room for the motors, which I have fully forgotten because I'm an idiot. Don't worry about it. So now we will attach the motors. So this one, we just plug in. Here is the finish bit, where you have to be a little bit like the way in which you get it in. Like you can do it a little bit like trickily, by like putting it in the middle and then like sliding it in and then rotating it. Then we take the motor screws and just attaching it by one. And I will just grab my mechanical assistance tool because I'm a lazy bugger. Just do like just add the screws here. And like if you by some stupid coincidence like drop a screw, it should be fine. Oh, people, as I said, it should be fine. But like try to at least even it out so it's on both of them. So that if you drop two, it's only like two you drop and not all of them. So there we go, and then we just tighten it to make sure all of them are at least attached with the same like torque. Yeah. So that was the first one. Now we just need the other one. Oh, and again, in through the side, whoopty whoopty. Oh, wrong way, that's why that felt too easy. Well, actually we can do it this way. There we go. So now we just add some glue on to keep it roughly in place. Just roughly in place, because then I don't have to put as much effort into holding it, which is nice. So yeah, you can also see me like swapping between like my mechanical one and my manual one, like screwdriver that is, because it's like some of them just have different like uses and different utilities. For instance, like getting a screw to match is a lot easier with like my sweet little one, because I have full control over that. Whereas the big one, it's a little bit more like hit and miss, because you can't feel like if it's plugged in the right way. We go. So now we have these. So now we can attach the wheels. So just take the wheel, flop it in. We've used like wheels that are rounded, which means they should be relatively easy to put on. But we do it like that. Slightly shuffle it in until it like is nice and snug. And we do the same again on the other side. And that went way further in. Cool. So there. And let's see if we can get the other one to go in as far. Just to. No, that one doesn't really want to go. Makes total sense. I think this one is the one that's drilled more recently, so it hasn't been like worn away as much. So now the next thing is that we need to attach the Raspberry Pi. So the Raspberry Pi is where all of the controls and stuff happens. So we kind of want to have this be attached. So let's start out by. Did I remember correctly that this was a 3 or was that a 2.5? Oh, it's 2.5. Then I did misremember. Well, we'll go just grab a 2.5. I have those lying around. Not that one. That's the long one. That's the long one. Not that one. The box. So now we're going to take the M2.5 for the Raspberry Pi, because I had forgotten that the Raspberry Pi actually uses a different port size than I had remembered. It's fine, it's just so we don't potentially damage anything. So now that I have the right size screw, we take some plastic spacers, just so we are away from anything conductive, because we really don't want to be anywhere near conducting material, because that can be a not great time. So here we will just take the the Pi, put it through the holes. There we go. So that fit a lot more nicely than the other ones did. There we go. This. And this. I think most of these are like 10 millimeters, so I hope they're long enough. Otherwise, I'll grab a different size. A piece that are long enough. Okay, it's fine. Just grab another size. That's the great thing about having multiples. Not that one, because of course I hadn't taken into account the new spacers being there, which makes everything longer. Obviously it did. Okay, let's just go with these few longer ones to begin with. Yeah, that should be fine. So here we're just taking some like, way too long ones, just because that's what I have like lying around right now. I'll like later cut them down to size. But here you should probably go with some 16 millimeters if you can. Otherwise, there we go. So right now I'm using, I think it's a 25 millimeters of space. So we just go whoop whoop into the hole, So here the orientation of the Pi is not super important. It's more of a, this will be nicer for you if you do it this way. Because if you do put it the other way, which you can do, like nothing will, like, it's not necessarily bad doing it the other way, doing it and the other way. So as you can see here, I don't have a bolt. That sort of makes sense because right now I'm using the plastic from below to act as my like threading. You shouldn't do this. There we go. Yes. So now we can do the proper thing or the proper way of adding like these knots to it, because obviously using a middle part is not really the nicest way of doing this. But like as you can see, like it will work. But yeah, back to why we want to have this this orientation is to make it way easier to attach the power. So if you don't attach it this way, the power cable is going to be a little bit more of a pain in the ass to get to. So right now it's here, but if you put it like here, you're going to have a lot of stuff in the way from the battery, or the battery will be in the way rather than just like straight over. So that's a thing we definitely don't want to have in the way. Yeah, so now we're going to attach the first sets of spacers. So here we've used the long one. I would recommend using the long ones. And I did a boo-boo. It should be fine. So normally I would do this before the motor is attached, but I forgot again. It's been a while since I attached this, so I'll probably see if I have a couple of the short ones. Let's see, that one should probably. A little bit of finagling here is highly encouraged when you do it wrong. Otherwise, yeah. That is sort of what happens. This is not the best guide on how to do it the right way. Come on, don't crack. There you go. Sehr gut, yeah. So now we can just hold it in and attach the spacer. Again, I highly recommend doing this before you add the motor, because if you do not do it at that point, this step is going to be a bit of a pain to do. Like I sort of just know how to do it because I've done it wrong so many times. I know how to deal with it when you do it wrong. As I've said before, I'm an idiot, and a big one of that. Now we can just do this. There we go. Put it in and add the spaces. A small note: the spaces without the external threading, or just the female spacers, are the ones we are using for the bottom plate. And it's very important that we use just these. The long females and the females with male at the end are for different purposes. So it's very important that we keep that in mind, that this is the way it should be, or this is the proper way of doing it. So right now we have the first layer. Now we need to add the next layer of the robot to it. But before we do this, we would want to put our switch for the third layer through here first, because this is the first step where this is going to be attached. So we're going to put it through and then attaching our reset switch right there. So now we can just do this, and then we only have one more thing to do, which is to get our LiDAR. So our wire for the LiDAR, wire and little control chip. I think it's like a small controller that converts from the signal pins that the LiDAR sends out to micro USB. So this we need to put through. Here we just want to use we just want to get the wire through, because then we don't have as much like. Then it's a lot easier to get it through. So we just get that end, this end through, and then that is basically all we need to take to really make sure we do now and not later. Before we do attach this, it's highly suggested and recommended to add the spacers now. Because if we do add them now, then we don't have to faff with having like our hands like in the way whilst we're doing like, or having the bottom plate in the way when we have to attach the spacers. So let's attach them. So now I'm able to do this, which is probably why we do it this way. Here, and this is for the foot. This is the spacers for the foot layer. So here we do it here, and this time we're using the spacers that are female on one end and male on the other end. The reason we're using these now are specifically because we need to attach them later, and once we only had like female, so we added a threaded rod to one end, and basically that is what this unit is, and that's the only thing different from like a male-female connector. Like it should just be a male-female, but we didn't have that available. So this is what we ended up doing as a way of getting around like the limitation of what was available to us. There we go. So now these have been attached. We can also, now that we have access to all of the things and are able to move it up and down, we can also attach the plate that is going to be used to attach our daughter board. That we can use, and we can also attach the radio communication or our Arduino Mega, which is providing that radio communication. For this, we just disattach or detach the daughter board, the board for that. Put that on the side for now, and then we can add this that way. So there's already pre-drilled hole or pre-made holes for all of these mounting points, so it should be relatively straightforward. Oh, here we use some spacers again. Right, was I wrong? Oh, that one we can use, that one we can use, but we're not. We're using this one, that one, and this one. Yes. So here we're just adding this spacer, and I hope the size is still long enough, because I haven't tested with these spacers either, because I just got them today. Oh, we just on the border. Great. Okay. No, this should be fine. This should be fine. Like, they're not gonna carry any weight, so this should be fine. Yeah, just, so right now I'm just flinging stuff around. It's fine. Like, none of the things that I've dropped / like thrown around or flinged around are like gonna be damaged by it. It should be fine. So we just do this, attach it slightly, so we still have like the movability of it. Oh, it's fine. Just grab another spacer. Add that underneath, move it to the side a little bit, plop it in, wiggle it upwards a wee bit. There we go. Take one of the obvious long ones, plop it in, and then going, you need to be a little further inwards. That was not a thin thing. Let's just do. Go, keeping it. There we go. So now that spacer's the right place. Just do at least like halfway through, so the space will follow along. Oh, and of course I did it wrong, so it didn't. Okay. So now, so now the spacer at least will follow around. That's what we want. Now we add the other spacer for this one. Let's see if we can do a little bit nicer this time. Let's see. There we go, caught it. Then we put
That was a short bolt. Dang it. There we go, and there we go.
Cool. Now we put 2 fingers on those screws, flip it around, at the knot, and as you can see, like we have very little space here. I would highly suggest that you get some 16 millimeters for this one, because I hadn't taken the spacers into account because I've just gotten them today. So that is a very important thing to at least make sure you know that the spacers will take up more space than you probably expect. So let's see, can we add it? Okay, at least it's somewhat added, and then let's see, can we get the other one? Didn't drop that far, so probably. Let's see. Yes, that one was very nice and easy to put in. So now we go around, do this, we hold it, and we tighten it. Of course, no tightness here, because if we do that, then there's a chance that we either break the board or break something else, and we don't want to do either. So we just take that care of, like, did I take a wrong knot or something? Let's try a different knot. I have a suspicion that something might be wrong with this knot. That or the threading here at the end of this one is being like super bad. Could also easily be like knowing the way I've treated them. Not really the most flattering thing. Let's just call that good enough for now, because it's not going to hold any weight. So now we have that. Now we just need to add this one. This one don't need any spacers, so it's gonna be nice and easy, I hope. But here, I know the size should fit. So there we go. That's one. There we go. 2. Of course, this is not really like, it's sort of like fine to do. Most of these things are like not as tedious as I've tried them elsewhere. Because I've definitely tried some like assembly where this was not made by people that know what they're doing. Neither is this, to be fair. I have very little experience with like manufacturing, production, and all of this. But at least I am trying. I'm learning how to do this the right way, and I do know that some of the things I've done are definitely not the right way and should probably be fixed in like later iterations of the robot. It's like very much a thing that happens when you slowly get into like this kind of production and methodology where you need to make sure everything is just not necessarily perfect, but good enough that like even I am able to like put it together, not necessarily in the right order, and it should still keep itself from destroying itself. There we go, and this one should be very loose. There we go. So now we have everything on the second blade. Through and pull through. There we go. Was that the right way? So make sure that you okay, so that is going to be like that. So yeah, I did that right way. So make sure that you line this up, like this connector up with how it's going to be on the Raspberry Pi, or sorry, the RP liner, because that's kind of important. Because if it doesn't line up, this isn't going to be nice to work with it. So now we can close it up, and when we've closed it up, we are basically done with the second layer as well. So there we go.
So now both the first and second layer have been like finished. So we can just do this. And pretty much, oh actually we still need one thing, but it's not as important. Good. So now we need to attach these two and those two. So now we want to attach our ball to the point that it's gonna stay at. So and here it's a little bit tricky to get it in properly without like a bit of tongue action, like having a tongue that can like hold the spacing, or the not the spacing, the knot. And I also definitely need a spacer for this, not a spacer, a safety thing, because I really don't want to short this across anything. There we go. Just taking a small one, putting it on, making sure that the connection is only on the threading. Yeah, and then just don't hurt. Then let's see if I can find this spot by just. Oh yeah, I did. Oh yeah. Hoo-wah. I'm a bloody maniac. Well, that's not really that surprising, is it? There we go. Go. Ah, right, there we go. It's just a little bit of faff there. I'm gonna take a knot, add the knot to the finger, plop it in, place it roughly right. Not 100%, but roughly right. Oh, see, I'm holding it wrong. Not wrong, but wrong place. There we go. There we go. So now the two screws are in. So now we can tighten it a little bit. Again, be careful, we don't want to break anything. This is just for like, there we go. So now the board is attached. There we go. So now that we also have it open, we can attach the wiring for the robot, which is going to be red furthest in towards the motor driver for both wheels, and make sure you don't like pinch any wires and stuff like that. There we go. Now we're going to attach the LiDAR to the third plate. The LiDAR is very easy to like distinguish how it should be, because right, I turned it upside down. Cool. So here we just take the short in 2.5 screws, add it to it, get just one of them in like slightly, so it still can rotate, and just take the rest, and just screw them in. Make sure they fit. Oh, that didn't catch. You catch it now. Yes. God. Go down here. Cord. And this one. So here we go. There we go. Tighten, 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 and tighten. So now, how those are long. That's fine. I have to change the size. That's fine. That's fine. This is not the final one. Anyways, so here now we will start attaching all of the like pins, the reset, and all of that switches. No chance I can do that. Yeah, let's do this. And call it high motor. Yeah, high motor. So now we're just attaching the. Oh, I have to remember what is what. That's on. So that way. Yeah. There we go. Now we just take one of the, take this, the bolt, attach it. Why is this not fitting? See, is it just this one being stupid, or is it all of them that's going to be stupid? Why is the threading flipping wrong on those, so different? Let's grab here, see if that one's just lying by chance out of the right thread style. Nope, that one isn't. Sizes are wrong. Let's just see what I can do about it. Even. Let's just see what I can do about it. So this is how it's gonna be. There we go, I attached it the right way. See, that's not what it was. Let's see if I have another one. Please, or if I have to be so fortunate. No, seems different. Seems different. Actually, that might be good. Like the most infuriating thing to distinguish because you can't. Let's see. This should probably do it. Let's see. At least one of them. Unless I'm just trying to get a different one. Let's just see if any one of these are the right way around. Or the right threading. Nope. Wrong. Isn't it great? Don't you just love when they have like basically produced the same switch between two different like well actually it's the same company, I'm pretty sure, who've done both of these switches, but like the flipping threading on the nuts of them are like different. And why
well, let's just make it more irritating to use. Instead of just using a standard, use a goddamn standard. There's a reason we have them. There's a reason we do it. We don't like to be forced into like these stupid situations where I'm sitting here going like, oh, why did we not work? And the answer is, this is constructed on. Which, to be fair, it's a thing. Don't worry about it. Oh, it's fun. Let's see. Yeah, go straight on immediately. So let's see. So now that's our power pin. So in the next iteration, or not next iteration, like when this plate gets printed the right way around, these won't be like placed as they are right now, where the resets are on one side and the power is on the other. It'll be flipped, so power is on this side, resets on this side. That's an oversight that I did this time around, because it's sort of hard to see it when you don't have it in your hands. At least it is for me. Slightly difficult to like understand why it has to be one way and not the other. So let's just add the remaining. Oh, that's the pie. This is the motors. Oh, that's really terrible sound. Yeah, come on. There we go. That's really uncomfortable. And the last one is this one, which goes with actuation. And so now only one thing left. It's to add the little LED here, so it fits in roughly, not the middle, that would be wrong to say, but you know, it's in that general ballpark. Now we just do a little bit of wire management and like, oh, I did not a boo-boo, but before I attach this, I should probably set it so that I have a little bit of space. Oh, I poked myself in the pin. So now we attach the top layer. There we go. Now that's attached. Do a little bit of cable management by just like shoving this like to the other side, so it doesn't get as annoying and in the way whilst it's like doing operations. There we go. And we just slowly, securely slide it down. There we go. So now all of the things are placed the way we want it for this layer. So now this layer is complete. But before we add the last touch, we will add the radio module, which luckily is far enough on the side, so we can just do it this way, like whilst it's still attached. There we go. So now the radio is available. So now I would like to go put this on the side for a little bit and take this and last two of these. So here it's going to be that way. So we're going to take it this way. Take spacers. We have this. Let's see, it's supposedly this one. Is this long enough, or did I miscalculate again? I did, obviously did. That, I know I didn't miscalculate, I just took the wrong one. Because I have those actually prepared. So here, longs. There. So this one I actually have prepared. I just put them away for whatever stupid reason. Yeah, who knows? Let's see. So we will put. So here we can see we need to put it here. Put the spacer through. Or no, we don't have to put a spacer through. I do recommend it just to avoid the worst that can happen with the bending and stuff that may occur when you try to attach it. So now just slowly tighten it on both side. Yeah, in the next iteration as well, we'll probably use like all 4 mounting holes just to make sure that this will be even more secure. Currently we haven't, but that is probably the next big step for this system. But yeah, not really important. That was just a side note. We need this now on the side. Then this. So what you can see now is most of the wiring isn't done. Well, that's because currently we're very close to also adding another setting to the system. So another setting, a different setup where most of these switches that aren't connected to anything will also be connected to the wire. So we can have the power wire for the TNC or the motor driver TNC be connected through the wire here. We can then turn off the power, reset the power. So let's say hardware failure happens, or not failure, but a hardware issue happens. We can reset it without having to deal with any of the grievances we can end up with that could occur. So this is just a way for us to have resets. We also want to be able to not just take the power for the from the motors, which is this specific LiPo battery. Or not just this, but a LiPo battery. We want to be able to both take the power from that, but also from the power bank here, so that we can take the power from the Raspberry Pi and the motors independently of one another. This is for multiple reasons. Sometimes we just want to like stop the motors so we can do some software checking. And sometimes we want to stop the Pi, which stops everything. Primarily to make sure that the battery will last longer, or not necessarily last longer, but won't use power whilst we're just like faffing with it. So, but yeah, now we're adding the last screws, or the double length extender screws, so that we're able to attach the final step, or the final layer. So let's just slowly attach everything, and when everything has been attached, there we go. Again, here the issue with the female-male system was again an issue or a problem. Therefore, these are also like 2 of the same heights attached with a threaded rod. So just so you're aware, if you're able to get these like a 70 millimeter spacer, use those. Like, it's a lot less hassle for you than this is for me. So now we just need the last 4 screws. Oh jeez. And when these 4 screws are in, we are done. Of course, wire management and all that is still a thing that needs to be done, but we are not like there yet. This is an alpha version of the fifth version, or at least it seems to be that I found a couple of issues that you normally find when you're like assembling the robot. That definitely needs some TLC to make sure that it's nice and secure, or nice to work with, for like not just people like me who have had way too much time with it to understand what's going on. So for now, we just need to add the batteries. There we go, just doing this. Plugging it in, then plugging the battery in. Go, whoops, there. Taking the power bank, plugging that in. Currently that doesn't have a wire going to the Pi yet. That's the first thing we're going to have, but we don't have that. So that is sort of a guide to how to assemble this and how not to do it. I do recommend that you watch it all through before you start doing it, because if you just do it alongside me, you will potentially do the same mistakes I did. and of course there will be an updated version of this later when we have done a little bit more like scripting on how to do it the right way, and maybe it won't be as much ruffle as it was this time. But this is the current version of the Rudolph V5. Yes.